All right. So I don't know if you've looked ahead at all at Module 9. We are going to spend only today on Module 9 because it's a small amount of content, and it's also going to be going back and revisiting an assignment that you've already done not too long ago, actually. It's A7, the employee database. So Module 9 and Assignment 9 are actually to add some more functionality to Assignment 7. I know many of you have not completed Assignment 7 yet. So the nice thing about today is that it's going to be a opportunity for you to double dip, so to speak, or in other words, sort of kill two birds with one stone. Whatever analogy or metaphor you'd like to use there is fine. But basically, I'm going to go through some of assignment 7 and give you some ideas on how you might want to approach that assignment. And you can actually turn in the same code for assignment 7 and assignment 9 because it's completely possible to satisfy both assignments with one set of code. So if you're struggling with 7, pay attention today, and then code it for both 7 and 9. Turn it in for both, and you'll be in good shape. If you finished 7 already and you have it working, then the amount of coding it will take to get it ready for assignment 9 should be pretty minimal. So before I jump into the assignment itself and the employee database work, I want to cover a little bit of new material. It's not much, but it is an important part of coding well in Python, and that is error handling. Now, so far, I've mentioned that there are basically 3 levels of error handling within Python or within Python programming. The first being giving good instructions to your user about what you want them to enter. We've kind of practiced that as we've developed different programs and things like that. The second level is checking their input, right? If you expect a number, checking to see if it's actually a number, doing that sort of thing. The third level is the most robust level, and it's actually error handling. So meaning when you have some kind of situation, let's say you're doing math, you're doing a calculator program that adds 2 numbers together, and you're asking the user to enter 2 numbers, and they enter the letter Z, right? You can ask them to enter a number, you can check to see if it's a number, but the most robust way to handle that is actually to catch the error when it happens. At the moment when you're adding those numbers together, and you realize that you're trying to add 7 plus Z, what happens next? What do you do with that? And the way you handle errors, the way you catch those in Python is with a block of coding called try and except. Okay? So if I say try this, one plus Z, and I have an except here, I might say, sorry, you can't do that. Now I know this is going to throw an error, right? So if I have this, let's comment all these other lines out. Okay, so I'm just going to run this terrible program that I've created. Okay, so I've got a type error here. Okay, because it's the hey dummy, you can't add an int and a string together. So that ends my program, and remember, I have an exit code of 1. When my program ends on a bad note, you get an exit code 1. You never want to end on exit code 1. That's just not good. So if I do try and except here, notice the structure again with the, I have try and then a colon. The stuff that I'm going to try is indented there. And then I have accept indented at the same level as try, so all the way to the left here. And accept has a colon after it, and then everything I want to be done in the accept block is indented at that level. Now, one thing you might be wondering is, oh, what if you have an error here? Like, what if I just say, sorry, you can't do that, +9? Well, then you're still going to end on an error. Your code in the accept block has to be valid as well. But usually what you want in an accept block is pretty simple, pretty straightforward. You don't want to put anything in there that's going to cause any issues. But if I run that now, look what it says. It says, sorry, you can't do that. I have control. I don't get that weird red error message that nobody understands. And look at my exit code, 0, which means I have 0 errors in my code. Even though I know I put an error in my code because I did it on purpose, that's really nice. Okay? Now, I can actually go through and catch specific types of errors and give really meaningful feedback. You can do multiple accept blocks here, and you can put in different types of errors. And if I look at, where is that? Home. If I look at the reading for this week for Module 9, some of those are in there, in exceptions. This is a pretty good textbook chapter. Okay. So if you look at this block, I can actually do that. And just like, okay, so now I have try, and then my accept says accept type error. So if I have that specific type of error, now I can do that. And I can have a generic one, just says accept. You can't add numbers and letters, right? So I'm actually getting into the type of error, and then if I can't figure out the exact type of error, then I have an accept with just a colon. So I have try, and then accept type error, and then accept, and then else. So if there's no error, this is what I do. Good to me. And else works just like an if-else statement. So basically, if I try to do that, print 1 plus z, we know it'll throw a type error, so you can't add numbers and letters. Okay, big deal. We got that. The accept is some other basic generic something occurred. And if everything works good, then it'll print that. Okay? And it will only do the else if there's no exception. Okay? It will only do the else if there is no exception. So if I run this now, you can see it'll say, sorry, you can't add numbers and letters because it's catching the type error. How do you know what error to look for? I would say cause it to throw the error that you think you might want to look for. So if I, again, comment my code out and I say, wonder what kind of error this would be. Boom, right here, that word, type error, capitalized in exactly that way, is the same. So I'm taking this from the error code, the type of error, and I'm using that in my code block. Word for word, copy and paste, super easy. Now, let's say I just leave that off. A syntax error is still going to throw an error that I can't catch. Okay, that's something to note. If you have an error in your code where you just forgot a closing parentheses or something like that, then you're going to have issues that are different and you can't catch. Okay, so if I have a 1 divided by 0, that should throw a different error. I can't divide by 0. That's mathematically impossible. So some other error problem occurred. And if I don't have any errors there, then it goes to the else. It prints the 1. It does the code in the try statement, and then it says whatever the else is. Now there are some cases where you might want it to do something whether the try succeeded or not. And in that case, instead of else, you will use the word finally. Finally happens no matter if there's an error or not. So again, if I go back to the 1 plus z, finally you should say something like, I'm done now. All right, there we go. Finally, with a colon and indented below that. Okay, so it still gives me the customized error message in the exception block, the type error, and then it says I'm done now, because finally will always happen. Now, one place where it's really good to use finally to keep yourself out of trouble with errors is when we get to working with files where we're saving data to the hard drive of the computer. Sometimes you could have an error that prevents, like if you're trying to write to a file, like you open up a file and you want to write something, you want to add some text to a file. If you have an error in that text and it causes your program to trip up and you don't close that file, let's say you have a line of code that says add the text and then save the file or close the file. If that line of text where you're trying to add the text to the file has an error, it won't close the file. And then the next time your program tries to access that file, it's open already and it's stuck in that state. So finally is a really good thing to remember when you're working with files, because you always want to use try, catch, and then a finally that says no matter what, even if the write is unsuccessful to the file, you still save it, you still close it, because you always want to clean up after yourself. That's an important programming concept, is sort of like, a lot of people refer to it as garbage collection from a coding standpoint, but basically you just want to clean up after yourself. You want to reinitialize variables, you want to close files that you open, all of that stuff. Okay? So this is sort of the third level of error handling in Python. And so it's what we want to add to our programs to make them super robust. So now we're going to go through, and I want to add this level of error handling to the employee database assignment. Okay? So we're going to get into the employee database assignment, where we're going to be working with nested dictionaries. And if you remember, a nested dictionary allows me to access, right, one name or one, oops, I didn't do these as dictionaries, that's why, name. I'll just do it real quick. That should be a string. Did you know that if you highlight a piece of text in PyCharm and you hit the quotes, it'll surround it in quotes? I think that's kind of cool. So it's going to be salary. Sorry, I didn't set this file up right. I set it up as a list inside a dictionary, but we want to do nested dictionaries because those are way more fun. position. Oops, there we go. All right, that looks right. Now I can do this down here, name. All right, so I can access employee number one, name. If I run that, it just should print Bill Mosley. Very good. So the dictionary works now that I fixed it with adding the keys. So this is our dictionary object, and we want to be able to add and delete employees, right? So I'm going to create custom functions for this that will allow me to add an employee. Now, one thing I know I'm going to have to check is to make sure that when they enter a salary, there's all kinds of things that can go wrong. If I'm entering a salary, right? I might enter something with a dollar sign in front of it. Or, we know it's a string when they enter it. So I've got to clean that up and make sure that that number is in the right format when I want to insert it into my database, so I don't get it confused. So let's do that first. Okay, let's create a custom function called clean salary. And we're going to take str input as a parameter. I spent the weekend coding in a different programming language, and now it's all tangled up in my brain. I probably shouldn't do that right before I teach Python, but oh well, too late now. Okay, so clean salary. We're going to take an input, which will be the user input, and we are going to have it spit out either a number or a 0. Yeah. How do I want to do this? It's a clean salary, clean budget. I want to do this a little bit differently. I'm not going to take any input here because I'm going to get the input from inside the function. And then I'm going to have it spit back. It's only going to return something once they have a clean salary put in. So that's how I'm going to do it. It's going to force them to. So like before, I'm going to set up a while true loop inside the function. Input, and we'll ask them for the salary. What is the salary? Okay. So now we need to try. Let's see, since we're being a little bit braver about this, let's see right off the bat, can we convert that salary to a number? If it goes into a float format, we know we're automatically set. Let's go FL salary equals float str salary. So we're going to just try it because we can right now. So if we have an exception there, now we have to get into a little bit more detail, right? If it doesn't work, Now we got to figure some stuff out. So if I want to figure some stuff out, let's try first going through the string character by character and seeing what's a number and what's not. Okay, so I'm going to create an empty string called str clean, and I'm going to put the numbers in that string. If it's not a period or a number, I'm going to clean that up. Okay, so let's go for str character, char, there we go, in str salary, if str char is numeric or str character equals a period, then I'm going to add it to str clean. Now I know that what I'm doing is going to be a number. It has to be. So I'm going to str character plus equals str clean. No, other way around. My bad. Okay, so I'm going to add that to that string. And then I'm going to, the very last thing is FL salary equals str clean. And I don't even think I need the while true loop now because I've accounted for every possibility. Either they're going to enter something or it's not going, or it's going to be, actually, that's not true. That's not true. If they enter nothing, right? If they just hit enter, I haven't accounted for that. That's still not a legal salary. So if I, down here after this, if FL salary is less than, is equal to 0, then print you need to enter a real salary. Try again. Okay, and then if it doesn't equal 0, we'll break that loop. Actually, we want to return FL salary, which will break that loop as well. Okay, so I think that covers it. Let's just try this out and see what happens. So clean salary, let's run that. What is the salary? $100. I should have had it print that so we can see, make sure that it's returning the right thing. So print clean salary. Let's hit that. Okay, that's interesting. So it didn't print anything. So let's say, or FL salary is, what would that be exactly? Null, empty? Is, that's not coming up. I can't because I've, let's see, str clean. Hang on, I didn't change it to a float either at that point. So I'll return the float here. There we go. I can check the length here. Let's try that. I think that'll work, right? Okay, so that got it. So as you can see, playing around with your error handling and actually trying to break it is the best way to test your error handling. And that is exactly the process I would go through if I was creating this. So now I can get a clean salary out of this. The other two functions I need to create at least are the add employee and delete employee. So let's go def add employee. Okay, so what do I need to add? I need to get a name, str name equals input is your name. I need a position, our position equals input what is your position. Okay, now I need to make sure that I'm getting input there. So I probably will go each one of these in a while loop, just a little baby while loop that says if str name equals empty, then actually I'm just going to go if it's not empty, then break. We'll take anything for a name. Maybe Elon Musk is filling out this form and for his child and named it something weird. Who knows? So the next one, I'll do the same thing. If str position, that's just a little error catching to make sure that nobody's messing with me by entering empty values. Okay. So I've got the add employee there. I've got the name and position. FL salary equals clean salary. So now I've got all three of those variables, and I know that there's something in all three of those variables. That's nice. What I need to do now is I need to get that number, which we talked about, right? Remember how we had a little function that returned the new ID? So let's get that. I'm going to jump up and create a different function. Next ID. And what I need to do is say for, let's do it this way. I'm going to get an int count equals 0 for now. And I'm going to say for index in employees, int count if int count is less than index, then int count equals index. So basically that's saying if this number is higher than this, which it will be at first, it's 0, but even if these are out of order, I'm going to get the highest one. And then at the end here, I'm going to say int count plus equals 1. I'm going to add 1 to it. There we go. And return int count. So that'll give me my next ID. Int ID equals next ID. Now I have all the pieces I need. This should have been its own little while loop. Copy, paste that there. So I just added another while so that these are separate loops. We don't want them tied together. And this should be unindented so that it's below the while loops. So now I have all 4 pieces of information. The last thing I want to do is add the employee record. So I'm going to say first thing I need to do is make that global so I can access that dictionary from within the add employee record. And I'm going to say the dictionary employees int ID equals new record. I'm going to call that DIC new record so we know what it is. Okay, so that doesn't exist yet. I need to create that record. So DIC new record right above that equals the dictionary object name and then str name, and then salary was next. Salary in quotes colon FL salary, and then finally position in quotes and str position. So now I'm creating this new employee record and I'm assigning it to this dictionary corresponding with the new ID. So now that should add that record, and I'll say new employee added. Okay, so there's that. Yes, sir.
So because the dictionary was created outside of the function, do you have to call it a method to call it as a global?
I do, yeah. See, there it is right there. Yeah. Only if I'm going to write to it. Remember, I can read a value outside the function from inside the function. I just can't change that variable. So if I'm adding that, I want to be able to change that variable or remove an employee. I'm going to call global from within those. I could, if I wanted to be really, really strict and clean about this, I could pass the whole dictionary in as a parameter and then return the whole dictionary when I was done. And then I would set that global dictionary object or that global dictionary variable to that new value. So it would technically be replacing all of the entries every time you ran that with the new list. So there's a little bit of trade-off there because one is more efficient than the other, especially if you're getting into like the hundreds or the thousands of employees. You will notice a performance difference once you get to a certain level. For our purposes, we're just keeping it rather simple. And this might be the better way to go, even though it's a little risky using a global. There are cases where a global is just so much more efficient that it's better. And this might be one of them. So let's run add employee and let's see how it goes. Did I not camel case that? I didn't. Oh well, I'll get over it. So I'm going to add the employee and then I'm going to print the whole dictionary object to see if it was added successfully. So what is your name? Dave, position, president, salary. Okay, so let's scroll all the way over. We should have a Dave here. Dave, salary, position. Nice. Now let's try and break it a little bit. What is your name? Okay, so it's forcing us. What is your position? Again, it will take, it's pretty loose at this point. It would take a number if I wanted to, but let's just go service and $150. Now remember, salary is a little bit more robust. We have to enter a real salary, but the nice thing is it's not blowing up, even though I'm actually causing errors in the program here. It's not blowing this part up. Those variables are safe, they're protected, they're in their own little space. So it's pretty happy for everybody. And at the end, we've got a program that's functional. Now, to remove, I'm not going to actually give you the code here, but I'm going to talk it through a little bit. Let's talk about what we need for a remove employee. So we define remove employee. We could pass it on an employee ID number, but I think what I would do is, if I was creating this, is first thing I would do is list the employees with ID. So that could be a function right there. That could be a separate function where every time you hit that, it's going to list the employees and show you their ID numbers. Get ID from user, and then all you have to do is use pop to remove by that ID. And it's going to look something like this, where we write DIC employee dot pop, and then we're going to use the ID number in here like that, and that's it. So remove employee is pretty straightforward. And then you probably want to do like a user message, which might include, here's a good reason to make that list employees, because you might want to show them the new list of employees. Here are your employees now that you've removed that one, right? You might want to use that up here in the add employees one too. So you can say, you added an employee, here's your new list of employees, or here's the employee ID that you added. I mean, there's a lot of things you can do there. So a list employees function would be a very useful tool here. Not necessary, not required, but useful. So to satisfy the assignment for number 7, you need to be using the dictionaries. You need to have custom functions. To satisfy the requirements for assignment 9, which is the module that we're on today, you need to include at least one instance of error catching, like we did here in clean salary. Okay, so you need at least one try and accept. I will tell you this, if you get a weird error with try and accept, make sure your indentation is right. But also you need to know that unlike an if statement, try requires at least one accept. You have to tell it what to do if you have an error. So every try has to have an accept. Okay? Any other questions? All right. So that is this. I'm going to get the video online for you all.